Topic 3, Equation and Inequalities. Under this section, um, we will discuss solving equation simultaneously. It can be linear or quadratic or combination of linear and quadratic. Why we need to solve an equation simultaneously? Because this is one of the method of finding an intersection points. So this is the first method to find the intersection point, and the second method is graphical method. Graphical methods. So we will discuss for both methods for two linear equations and a quadratic and a linear equation. So this is an example. So I am going to solve this equation simultaneously. We know there are two methods we learn in year 11 of JCSE. One is elimination method, the other one is substitute method. So I'm going to use elimination method to solve this linear equation. So I'll name this one 1 and 2. I can see that I can make coefficient 3 in this y variable. So I'm going to multiply by equation number 2 by 3. Then it will become 6x minus 3y equal 69. This is I'll name as equation 3. Now I'll add 1 and 3 together. This will give 2x plus 3y. This is the left side of 1 plus number 3, 6x minus 3y equal right side now 8 plus 69. Now this is 2x plus 3y plus 6x minus 3y equal 77. Now this is cancel out minus 3y. So before that I can see that this is equation number 2. So 3 times 3 not 6, it is 9. 9x minus 3y. So this is become 9. So then 11x equal 77. I can divide both sides by 11. Then x equal 7. Now I'm going to substitute x equals 7 to what is the best equation of number 2. From 2, 3x minus y equal 23. 3x equal 23 plus y. So y equal 3x minus 23. So here 3x minus 23 equal y, then I write y equal 3x minus 23. When x equals 7, y equal 3 times 7 minus 23, which is 21 minus 23, 3 times 7 and minus 2. So y value is minus 2. So we found out the equation of those two intersection point. Intersection point of those two lines is x value is 7, y value is minus 2. And now I'm going to discuss a graphical method to find the coordinates of intersection point. First of all, I like to have a rough idea about those two equations. So, question 1 from 1. I can write 3y equal minus 2x plus 8. Plus 2x, when you go to other sides, become minus 2x. Then I can divide by 3. Why I did? Because now this is y equal mx plus c form. So I can see the gradient of this curve. It is a negative gradient. And it has a positive y-intercept. So then this kind of equation I am expecting. Right, this is negative gradient, and when x equals 0, y equal 8 divided by 3. So this is the idea I have in this equation. So I'm going to look at the second one now. So 3x equal 23 plus y, then y equal 3x minus 23. So y equal mx plus c form. I can see m is 3, positive gradient. Here m is minus 2 over 2, and c is minus 23. So this is going to be like positive gradient. It means it should be go in this form, and it has a negative y-intercept. It means something like this. So this point is, we know, 0, 23, and something like this. Now I want to find, so I have an idea now. So I want to find the intersection point. It means I believe that the other graph go like this. This one. So this is curve number 2, and this is curve number 1, and so this is the intersection point. Now, how do we do this one graphically? So we have to draw a sketch properly. So then we'll discuss this one. Now, to draw a line, how many points you need? You need minimum 2 points, and 2 points is enough. To draw equation number 1, 2x plus 3y equal 8. So I need 2 points. So you can find 2 points by taking two values, assuming one value for x or y, and then you can find y. So first of all, I'll take usually we have 1 point is this one, 0, 8, 3, 8, 3. Or same one you can find when x equals 0, y equal 8 divided by 3. Now we have 1 point, but there's a small problem with this point, because 8 divided by 3 is decimal answer. It's difficult to draw in the graph. So then I rather like not to go x equals 0. I'll go x equal 1 and see that. Then x equal 1, 2 times 1 plus 3y equal 8. So 2 plus 3y equal 8. Then 3y equal 6, y equal 2. Alright, so that is a good one. X equal 1, 1 and y equal 2. You can easily draw this one. So this is a good one. So we will pick up this one. Then the other standard method is we are finding the roots, making y equal 0. Then let's see what is happening. When y equals 0, then 2x plus 3 times 0 equal 8. So 2x equal 8, x equal 4. That is also a good value. So when x equal 4, 0, you can draw this one on your graph easily. So we have 2 points, 1, 2 and 4, 0. So we can mark on the graph and 1, 2 and 4, 0. Now we'll find a good point for the equation number 2. 3x minus y equal 23. Then y equal 3x minus 23. So when x equals 0, yeah, y equal 23. So 0, 23 is not a decimal. There are no decimal numbers, so we can easily mark. What else? Then y equals 0. Okay, so to find the roots, y equals 0. It's not necessary, but y equals 0. When y equals 0, 3x equal 23. So x equal 23 over 3. So this is not a good answer. Then we want to either find another x1, x assuming x, so another y, assuming y. How about y equal 1? So then y equal 1, 1 equal 3x minus 23. So then 24 equal 3x. Divide by 3, x equal 8. That's a good one. So 8, 1 is another point. So to draw this 2, so we have 2 points now. So we can mark on this roughly. This is for this one 1, 2. 1 and 2 somewhere here. This is the point. And 4, 0. Somewhere here. 4, 0. Right. Yeah. So this is 1. And the other one is y0, 0, 23. Okay, 0, 23 somewhere here. And 8, 1 somewhere here. So this kind of graph. But we have to draw in a scale by properly mark x and y axis. So which you can see the proper drawing on in your books, page number 43. If you look at page 43, example 4, you can see how do they draw on scale graphically, according to a scale graphically. And when you draw graphically, what you can see that, so this is the intersection point. So then you can bring the ruler and you can find the x value and you can find the y value of this intersection point. So this is the answer. From previous answer, we know that this value is 7 and this is minus 2. Right? This is 7 minus 2. So this is still a sketch. You have to do a proper drawing. Now we are going to discuss quadratic simultaneous equations. In other way, solve quadratic equations simultaneously. So it can be in this form: y equal mx plus c and y equal ax square plus bx plus c, or two quadratic equations: y equal a1 x square b1 x plus c, y equal a2 x square b2 x plus c, c1 c2. So to find the intersection point of the curve. So we'll discuss an example now. X plus 2x plus y equal 3 and y equal x square minus 3x plus 1. So I can use simple elimination method or substitution method. So if this is 1 and this is 2, I can see that this is y and this is y. I can take 1 minus 2 to eliminate. So 2x plus y minus then the left side of the second equation, which is y, equal 3 minus, if there's expression, we have to write in the bracket with the subtraction, x square minus 3x plus 1. So this is cancelled out. So 2x equal 3 minus x square, minus times plus minus, minus times plus 3x, and this is minus 1. So I'll bring everything to left side. So x square plus 2x here, and this is minus 3x from the other side, and minus 3 here, and plus 1 I bring to this side. So x square minus x minus 2 equal 0. Also, you can use simplify this equation by substitution. So from 1, I'll show you that one as well. From 1, you can write y equal minus 2x plus 3. So then substitute 1 to substitute y equal minus 2x plus 3 to 2. Then, so this is the equation number 2. So you can write this is y. Instead of y, you are writing now minus 2x plus 3 equal x square minus 3x plus 1. Now you can simplify x square. I'll take everything to other side. X square minus 3x plus 2x minus 3 plus 1 equal, this side is 0. So I'll change to this side. It is 0. Again you will get x square minus x minus 2 equal 0. Still the same equation. Now you can factorize this one. X minus 2, x plus 1 equals 0. X minus 2 equals 0, or x plus 1 equals 0, x equal 2, or x equal minus 1. Now we can find the y value. So I'll take this as 3. Uh, from 3, when x equal to, y equal 2 times 2 plus 3, which is y equal minus 4 plus 3 minus 1. So then one point is 1 into 2 minus 1. When x equal minus 1, y equal minus 2 times minus 1. Always when you sub negative values, we have to sub in inside the bracket. So plus 3, this is plus 2 plus 3, 5. So minus 1, 5. So those are the two intersection point of the graph. One is minus 5, 5. Another one is 2 minus 1. So we solve simultaneously to get the intersection point, coordinate of intersection point. Now I'm going to discuss the graphical method to find those two intersection point. So for that we have to draw a graph in scale, but before that we will have a sketch on it. Now I need to draw this line first. So then I need 2 points. So 2x plus y equal 3. I will assume x equal 0. Then 2 times 0 plus y equals 0. Y equal 3. So one point is 0, 3. I can take x equal 2 or x equal 1. Then 2 times 1, y equal 3. Y equal 3 minus 2, 1. So 1 and 1. That's enough to draw this one. Or else you can take a different point with this one. Usually we'll go with y equals 0. Then 2x plus 0 equal 3. X equal 3 divided by 2. So 1.5 also not a bad point. So 3 divided by 2, which is 1.5, 0. So select any combinations and then we can draw the line. Now we are going to sketch y equal x square minus 3x plus 1. How did you do when you were doing a GCSE? So basically we draw values. This is x and y. So minus 3, minus 2, minus 1, 0, 1, 2, 3. So then you can substitute those values and you will find the easy one is when x equals 0, those two terms become 0, y equal 1. When x equal 1, 1 minus 3 minus 2 plus 1 minus 1. So likewise you have to find the values, then you will get the coordinates. So 0 1 1 minus 1 likewise, and then you can mark, and you can mark the points and you can draw the curve. So but I'll do a sketch on this one, not a proper drawing. How do we sketch this one? When x equals 0, y equal 1, y equals 0 minus 3, 0 plus 1, the answer is 1. The graph cut at 0, 1. I know this is going to be like this. Then I know this a equal 1 greater than 0, it has a minimum, right? Graph has a minimum. So I want to find that minimum point. So the technique I am going to use is completing a square. X minus 3 over 2 square minus 9 over 4 plus 1. Actually, I rework this one. X square minus 3x, half of minus 3 is 3 over 2. So I'll add 3 over 2 square. Then I minus 3 over 2 square plus 1. So this sentence 3 over 2 square, and this is the remain, so this is 9 over 4 plus 1. X minus 3 over 2 square, 9 over 4 plus 4 over 4. X minus 3 over 2 square minus 5 over 4. Now I know when x minus 3 equal 2 equals 0, x equal 3 over 2. So x equal 3 over 2 is the symmetric line, and minimum point at y value of minimum minus 5 by 4. So basically this kind of graph, this is the sketch. It's not a proper drawing, but this is the sketch. And then 0 3, I'm going to draw the line in this graph. 0 3 somewhere here, and 1 1 somewhere here. So I can draw this one. So those are the two intersection point when you draw properly. So bring a ruler, and you want to find the x value and the y value, and same as for this x value and y value. But we know that what is x and y. Previously we solved simultaneously. This one is 2 minus 1, and this one is minus 1 5. Now you can see the proper drawing for this graph is at page 43. of your book. In your book, page 43, example 5. Now please look at page number 44, chapter 3, page number 44. I'd like to bring your attention for that the top part. You can see that some explanation there for a pair of simultaneous equations that produce a quadratic equation of the form a square plus bx plus c form. If b square minus 4ac greater than 0, two real solutions. And b square minus 4ac equals 0, one real solution. Or repeated roots or one real solution. And b square minus 4ac less than no real solutions. So when we have a pair of simultaneous equations that produce a quadratic equation. Now, this is a pair of simultaneous equations that produce a quadratic equation. But this is also a pair of quadratic equation. Okay, I'll put 2x plus 3. That doesn't produce a quadratic equation. When you try to solve these two, this x square and x square cancel out and you will get 2x plus 3 equal 0. So this is a linear equation because it has only one solution. So we are talking about when we solve two simultaneous equation that produce a quadratic equation. Usually quadratic equation produce when you solve a linear equation and a quadratic equation. So we discussed this example earlier. So what is the quadratic equation relevant to this one? You can remember that x square minus x minus 2 equals 0. You can solve if you can't remember those terms. X square minus x minus 2. So this is so we solve those two equations simultaneously and we'll get the quadratic equation. So shall we check whether this equation has two solutions basically. We can check b square minus 4ac value. And this value, if greater than 0, then two solution. A equal 1, b equal minus 1, c equal minus 2. So b square minus 4ac minus 1 square minus 4a minus 2. 1. So minus become minus plus 8. 9 greater than 0, then there are two solutions. And we know that is x equal minus 1 and x equal 2. Likewise, if b square minus 4ac equals 0, so you have one solution, and b square minus less than 0, you don't have any solutions. Why? Because it doesn't crosses the graph each other, linear and this quadratic graph.